well. Okay, so now in this, we're going to see, as I told you, the introduction and importance of chemistry, right? The introduction and importance of chemistry. And here, let us first see the what, why, and where of chemistry. We're also going to see since when is chemistry into existence. Okay, so let us see that one by one. So what is chemistry, right? If I ask you what is chemistry, then you should not be in a fix that how should I define chemistry. You should know how to define chemistry. So here, let me take you for a ride. Let me take you for a ride in the universe. Okay, so in the universe, you can see that there are, I mean, everything. Universe is the totality of existence. That means you can see. I mean, we have everything in the universe only. Our Earth, our planet Earth, the other planets, our solar system, the sun, moon, stars. Okay, then galaxies, meteorites, asteroids, comets. All this is there in the universe. And in the universe, when we are having matter, okay, all this is what, all this planet, star, moon, earth, comets, asteroids, all this is made up of matter. So if you talk about chemistry, it is there in all these forms. Wherever there is matter, there is chemistry. Okay, so now even if I show you about the Big Bang theory, okay, even if I tell you about the Big Bang theory, that is, you can say the origin. This is a theory for the origin of the solar system. Okay, so there was a big explosion in the center, and after that big explosion was there, what happened after that? Okay, after that big explosion was there, this big explosion, okay, this big explosion blew up certain particles, and these particles were moving with the speed of light greater than speed of light. So when this explosion happened, like this was the particle, it was going with the speed of light greater than speed of light. And when a particle moves with this speed which is greater than speed of light, it started losing protons, electrons, neutrons, and new elements. For example, if fluorine loses an electron and a proton and a neutron, it will convert into oxygen. If oxygen loses an electron and a proton and a neutron, it will convert into hydrogen. If hydrogen loses an electron and a proton and a neutron, it will convert into oxygen. If oxygen loses an electron and a proton and a neutron, it will convert into carbon. If carbon loses an electron and a proton and a neutron, it will convert into hydrogen. If hydrogen loses an electron and a proton and a neutron, it will convert into oxygen. If oxygen loses an electron and a proton and a neutron, it will convert into carbon. So this is the Milky Way. Okay, so the Milky Way is also made up of matter. Okay, so even our solar system, as you can see over here, even that is made up of matter. And even if I take you back to the Earth, okay, then Earth also is having everything made up of matter. So our solar system, all the planets and their natural satellites like moon, everything, they are all coming under matter. So if I take you back to the Earth, right, even in the Earth, everything is whatever you can see or whatever you cannot see, that is air. You cannot see air, but still that is coming under matter. And what is matter? So matter is anything that occupies space. Okay, matter is anything that occupies space and has a definite mass. Matter is anything that occupies space and has a definite mass. That is called as matter. Okay, we have done. You have done in your lower classes what is matter, right? So everything on the Earth and in the universe is made up of what? Matter. So if anybody asks you what is chemistry, we can say that chemistry is the study of composition, properties, and structure. Also, the transformation of matter from one form to the other form, because matter can neither be created nor be destroyed. It can only be converted from one form to the other form, and the total universe, the total matter, always remains constant. Okay, so this study of the composition, properties, and structure, okay, and transformation of one form to the other form of matter is called as what? Is called as chemistry. So if you have, say for example, a chalk, right, a chalk piece, right? And that is matter, of course. Okay, so if you study the composition of chalk, that is CaCO3, it's having one atom of calcium, one atom of carbon, three atoms of oxygen. Then, if you look at its properties, yes, it is insoluble in water. Then it is white in color. Then it is having a melting point of, say, for example, 200 degrees Celsius. Then its molecular weight is 100. Then it you can write with it. It's having when you heat it, it will evolve carbon dioxide. So all these are the physical and chemical properties of water. And then the structure of calcium carbonate, if you draw the entire structure as we used to draw it in the radicals, then you will understand the structure as well. So if you're studying the composition, the properties, the structure, and the transformation of matter, all this will come under what? It will come under chemistry. So all this comes under what? It comes under chemistry. Okay. So now we have understood what is chemistry. Okay. If anybody asks you what is chemistry, you can immediately answer it is the study of composition, properties, structure, and transformation of matter from one form to the other is called as chemistry. So what is chemistry? तो भाई समझ में आ गया. Now where is chemistry? Okay, so where is chemistry? Chemistry is there in the fragrance of flowers. The fragrance is chemistry. If you're talking about rose, then rose is having a special chemical called as geraniol, and that geraniol is generating that beautiful fragrance of chemistry. Then even if I talk about the color, right, the beautiful colors of the flowers, like purple colors because of anthocyanin, then yellow colors because of xanthophylls, green color is because of chlorophyll, then uh, the orange color or the orangish red color is because of carotenoids. Okay, so all these are pigments, and these pigments are chemicals. So you can see that chemistry is there in the colors, it's there in the fragrance, it's there in the touch of the flower. The touch is smooth, soft because of the waxy coating. So waxy coating is again coming under what? Chemistry. Okay, not only this much, but also the air which we breathe. Okay, the air which we breathe in, okay, that is oxygen. So that oxygen is also coming under what? Chemistry. Okay, and not only this much, but the water, right? So water is the most essential component, right? Water, air, oxygen, these are very important natural substances which we require to survive. And water is also our principal cleansing agent. So all these are requiring what? They are requiring, yeah, uh, to understand this, you require what? Chemistry. What is the structure? It's also compound H2O. The molecular formula is H2O. How is the structure? It's having a bent T-shaped structure, the geometry of water molecules. So all these things, for understanding all these things, we require chemistry. So these were the natural substances. Now let us see the man-made substances. Man-made substances like laptops, mobiles. You are using laptop and mobile right now, or any other electronic gadget like tab or something, which to attend this session to get in touch with what we are doing over here. So again, you are using what? Chemistry. So not only that, but if you talk about your Wi-Fi cable, okay, that Wi-Fi cable, if it is a carbon fiber, okay, carbon nanotube. This carbon nanotube is made up of fullerene, which is an allotrope of carbon. So again, that optical fiber is again there. Wi-Fi cable is again what? Coming under chemistry. So there are different allotropes of carbon, as you know. Like diamond is an allotrope of carbon, graphite is an allotrope of carbon, kajal which you put in your eyes, lamp black, that is an allotrope of carbon. Then apart from that, charcoal is also an allotrope, amorphous allotrope of carbon. Okay, then apart from this, chemistry is also used. Like we were asking, where is chemistry? So you can see that chemistry is. I should reframe the question that where you can tell me a place where there is no chemistry. Like everywhere there is chemistry. It's there in each and every area. So even in treatment of thyroid, we require what? Iodine 127. So that is also requiring chemistry. Then treatment of cancer requires cobalt 60, diagnosis, treatment. So here also in treatment also we are requiring chemistry. So there is not a single place where we don't have chemistry. Chemistry is everywhere, and that's why it is so very interesting. Now, why is chemistry? Like since when is chemistry? Since the Big Bang theory, and even before that, chemistry is there because there was something, right, and that something was matter, and that matter was again chemistry, right? Now then why is chemistry? Because why I should study chemistry, or why is chemistry into existence? Because all the things around us, all our daily needs, that is also requiring what? Chemistry. That is also requiring what? Chemistry. Say for example, you're sitting in a room right now, that room is having some walls, and the walls are painted, so that paints again chemistry. inside that there is cement. That cement is also chemistry, because cement is formed in a chemical factory by chemical engineering using certain components like calcium carbonate, silica, calcium silicate. Calcium silicate is one of the major components in cement, right? And so on. So many things, like not only this, but your personal hygiene stuff, your soap, detergents, then again, the things which we are using for cleansing clothes, all these are coming under chemistry. Then even the carbon fibers, which is like 3 times more stronger than steel, it is used for coating of helmets and sometimes coating of cars as well. So that is carbon fiber. Then also in photography, right? Also in photography, we are using chemistry that is, in earlier days, we are not having cameras like these. We had cameras with reels and rolls. Do you know that? With negatives, it was called as negatives. One roll was placed behind the camera. I don't know whether you are aware of all this, right? A roll was placed behind the camera, and then that roll would rotate. There would be a motor, a reel was there, and that would capture your image, like how retina captures your image in the eye. Like that, it would capture the image, and that's how it would then later on we had to use a chemical reaction to develop that negative image into a proper colorful picture. Okay, so again, that was again chemistry. Then now you are able to see this. You're able to see this, why? Because of a chemical reaction which is going on in your eyes. And which is that chemical reaction? That is rhodopsin splitting into rhodon and opsin. So that is also nothing but chemistry. Okay, you are able to see because of biochemical reaction. You're able to digest food because of a biochemical reaction. There is HCl in your stomach that is reacting with the proteins, carbohydrates, and lipids which you have eaten, and that is how your food is getting digested. Yes or no? So, can you tell me which is the world's most costliest camera? Anybody who knows which is the world's most costliest camera?
DSLR.
DSLR? No, there are even costlier cameras than DSLR. We have mirrorless
The
also, which is
Canon.
even more costly. Canon is more costlier. Yeah. Anybody? Which is
Nikon.
the world's most costliest camera? Somebody's selling
The
Canon.
GoPro.
Somebody's selling Nikon. GoPro.
Oh,
Somebody's selling.
Pro is the starting price is 35,000.
Yeah. So let me tell you that all these brands are there, but the costliest camera is your eye, right? So your eye functions exactly like a camera. In fact, a camera is built on the concept of an eye, right? Your camera, you're the
Yes,
most,
the
I would
lens
say,
and that.
yeah, the most priceless camera, I would say, is what? Your eye, because eye is also having a shutter, it is also having a lens, it is also having a retina, like how the camera is having one place to capture the image, like that. It is also having it is converting, yeah, the image into electrical signals, sending it through the optical nerve, and from the optical nerve it is going to the occipital area of your brain, and there your image is being formed, and the image is formed, which is real and inverted. Your brain makes it that ulta thing, it makes it sulta, so that you are able to see that real and inverted image as proper thing. Otherwise you would be able to see everything ulta, inverted. Are you seeing everything inverted? No, you're seeing everything normal. That is because your eye is designed, eye and brain are working in coordination, and that's why you are able to see. Okay, so then not only this much, but your cosmetics also require chemistry. There's a lot of chemistry involved in making a person look more beautiful, increasing the aesthetic appeal of that person, right? Then personal hygiene, like two-in-one shampoos, innovation, that is innovation, self-cleaning clothes, then toothpaste, all these are coming under what? Chemistry. All this is being done with chemistry. Then medicines. Okay. By the way, I would like to tell you that my specialization is in medicinal chemistry. Okay. And I have the authority license to prescribe medicines, also prescribe, procure, and keep medicines. Okay. So now these medicines are what? These medicines are chemical substances again, which is required to heal you. Like if you are having a high temperature, you take crocin, that is paracetamol. That paracetamol is healing you. It's coming back to the normal temperature. It is bringing back your body temperature to the normal. Okay, so that is one more thing. That is again chemistry. Then if you talk about agriculture, then agriculture is again requiring pesticides like DDT, dichloro, diphenyl, trichloroethane, then fertilizers like urea, ammonium phosphate, and so many other fertilizers which are required to help your plant to grow and also protect your plant from insects. Okay, so not only in agriculture, but then if you talk about chemistry, it's divided into these branches like organic, inorganic, physical, biochemistry, and analytic chemistry. Let's see one by one. What is organic? Organic is the one in which we are dealing with substances which are obtained from plants and animals. Let that be your clothes. Clothes are obtained from plants and animals, right? Your clothes are made of cotton. Cotton is obtained from plants, or they are made up of wool. That wool is obtained from, yeah, that wool is obtained from sheep. So everything and anything and everything obtained from plants and animals, and also the things which we are hydrocarbons and we are synthesizing it in the laboratory. So all that will come under what? Organic chemistry. Okay, then inorganic chemistry is what? It is the study of all other elements except for hydrocarbons. Then NaCl, all salts, acids, then hydrochloric acid, water also, right? All this will come under inorganic chemistry, right? Then after inorganic chemistry, we are having physical chemistry, wherein we study the convergence of solid to liquid to gas, how much heat is absorbed, evolved, all that will come under physical chemistry. Even your chemical bonding comes under physical chemistry. Your atomic structure also comes under physical chemistry. Then talking about water, yeah, changes of transformation of water, all that will come under physical chemistry. Okay, then here we are having biochemistry, like now everything and everything related to your cells and to your body. Yes, studying the chemical structures of your body, like your cell is having carbohydrates, proteins, fats, lipids, all that is studying the structures of that, studying the composition of that, studying the properties of those chemical structures, and what happens if we change those chemical structures. All that will come under biochemistry. Okay, then analytical chemistry is analyzing. If it is analyzing of your blood or urine sample, or it is analyzing of your kidney or liver function test, kidney function test, analyzing of anything. Even if I give you a powder and ask you to analyze, yeah, go into the laboratory and find out what is there in this powder, whether it's having calcium ions, magnesium ions, potassium ions, which ions is it having. So if you do that analysis is done on the basis of analytical chemistry. Like what we did in practical chemistry was the last chapter. Practical chemistry was a part of analytical chemistry. Okay, all that is a part of what? Analytical chemistry. So here you can see that the different applications of chemistry over here. So chemistry can be applied in metallurgy, agriculture, environmental science. Then it's also applied in pharmaceutical science, then forensic science, and biological sciences as well. So it is applied in all different areas. Okay, so metallurgy, like if you want a metal, okay, if you want a metal rod, what you'll do, you'll go into the soil. See, metals are obtained from the soil, so you'll put your hand in the soil and pick up that metal rod. Is it? Can you do this? Can you do that? Just like how rickshaw wala starts this rickshaw, right? You put your hand and then can you pull up a rod like that from the soil?
No, sir.
No, sir.
No, right? You have to perform a series of chemical reactions so that whatever metal is there in that soil, you can obtain that metal. So that is also coming under what? Metallurgy. So metallurgy is again a part of chemistry, and not only metallurgy, many other branches which we saw just now. So till here we have finished this was the introduction part. Then I told you we are going to have a quiz kind of thing, wherein you are going to tell me that which radical is having how many protons, electrons, neutrons, all that you're going to tell. Okay, so let us see that quiz. I hope you understood, enjoyed what we did just now. I've taken a lot of efforts to make these kind of PPTs. I'm working on the visuals, I'm working on the presentations, right? It is taking me long
Yes,
hours.
sir.
I hope it is bearing fruit. I hope you are understanding what we
Yes,
are
sir.
doing over here. Yeah,
Yes, sir.
yeah. Atharva, Atharva, are you here?
Yes, I'm there.
Yeah. Did you understand and like what we did just now?
Yes, sir.
Yeah. So let's move on to the next part now. Let's move on to a few questions, right? So see what we're going to do over here is finding number of fundamental particles. Okay, fundamental particles in a given atom, ion, and species. Now, what are fundamental particles? Fundamental particles are the protons, neutrons, and electrons. What are fundamental particles? They are the protons, electrons, and neutrons. Okay, so if I'm having an atom over here, ladies and gentlemen, it's very interesting to note. If I'm having an atom over here, right, and it loses one electron, right, the moment it loses one electron, it will form a positively charged cation. Yes or no?
Yes.
Yes, sir.
Yeah, like if it was sodium, right? If it was sodium and it was having like 1 electrons in the outermost shell, 2 electrons in the first shell, 8 electrons in the second shell, right? And 1 electron in the outermost shell. And if this 1 electron got removed, so that entire shell is only gayab. Now we are having only two shells, right? Two shells are having 2 electrons and 8 electrons over here. 2 comma 8, 1 electron is less. And if 1 electron is less, we have seen that earlier sodium, this sodium was having 11 protons equal to 11 electrons. But now this sodium is having 11 protons, but 1 electron is less. And as 1 electron is less, ladies and gentlemen, as 1 electron is less, 1 proton is greater, and 1 proton is greater. That's why we write that plus one charge. That's why we write that what? Plus one
Plus one
charge.
charge.
Okay. And as we write that plus one charge, that is the reason for why it is formed and cation. Now this sodium, we call it as what? We call it as a cation. Sir, and what is this IE1? What is IE1? IE1 is the ionization enthalpy. Ionization enthalpy is the amount of energy required to remove an electron from the outermost shell of an isolated gaseous atom. So please write this down. Ionization enthalpy. Please write this down in your notebook. Ionization enthalpy. Amount of energy. This is the amount of energy. I hope you are writing down the definition. This is the amount of
Yes.
energy. Yeah. It is the amount of energy required to remove. It is the amount of energy required to remove an electron. It is the amount of energy required to remove an electron from the outermost shell from the outermost shell of an isolated gaseous atom. From the outermost shell of an isolated gaseous atom. From the outermost shell of an isolated gaseous atom. Yeah, please try to learn this immediately. The amount of energy required to remove an electron from the outermost shell of an isolated gaseous atom is called as ionization enthalpy. Please complete the sentence. Is called as ionization enthalpy.
Yes, sir.
Yeah. So what did you understand by ionization enthalpy? It is the amount of energy. Amount of energy for what? To remove
Re-
an electron.
Required to
To
remove
remove
an
an electron
electron from an
from
isolated
where?
gaseous atom.
Yeah. What is the meaning of this isolated gaseous atom? What do you mean by this isolated gaseous atom? Now you are sitting in a room. That room is having a door. The door is having a latch. The latch is made up of metal. So that metal has to be first converted into the below. That metal has to be first converted into the gaseous state. Okay, it is in solid state. It has to be converted to gaseous state. Then isolate an atom. Isolate one atom from that. And after you isolate an atom, and after you convert it into gaseous state from solid state to gaseous state, after that, whatever energy is required to remove an electron from the outermost shell, outermost shell will be called as ionization enthalpy. So it is not just removing an electron from the outermost shell of an atom, but you have to first isolate it, convert it into gaseous state, and then remove an electron from the outermost shell. Although all this is hypothetical case, but that is ionization enthalpy. That much is the amount of energy required to remove an electron from the outermost shell of an isolated gaseous atom. Understood this?
Yes, sir.
Ionization enthalpy.
Enthalpy.
Okay, so yeah, have a look at this. Yeah, in an atom, electrons are revolving around the nucleus. This is basic. You already know this. Protons and neutrons are present in the nucleus of an atom. You know this as well. Okay. So this is your nucleus. Protons are present. This is your first shell, outermost shell, and electrons is revolving. Okay. Is electron revolving?
Yes, sir.
Yeah. Then after that, this is an atom, right? This is a better diagram of an atom, and the right diagram of an atom you will see in 11th standard. Okay, these are still, you can say, primitive structures for you to understand. Now, what is the number of protons? Number of protons is equal to the atomic number. You know that atomic number is nothing but the number of protons, which is also equivalent to the number of electrons, because atom is electrically neutral. So it is also equivalent to the number of electrons, right? And if you talk about the mass number is the summation. Summation meaning Roman. Summation meaning what? Summation is the addition. Addition of what? Addition of protons and neutrons, right? It is the addition of protons and neutrons. Harshita, are you understanding? Harshita, are you here? Is
Sir,
Harshita
she is
here?
not here. She said that she is traveling, so she cannot join.
Okay, Srujal is here. Srujal. Srujal. Hello, Srujal.
Sir, he is there, but he is not
Yes, sir.
responding. Yes, sir, he can.
Yes. Which game are you playing today, Srujal?
No, sir, I'm not playing any game.
You are paying attention, na? Pakka, na?
Yes, sir.
Yeah, then what took you so long to respond? Then Sahil Gauri, are
Sorry,
you paying attention?
sir, I was in a hurry.
Hari, okay. So tell me, Sahil Gauri, are you here? Sahil Gauri and the other Sahil, two Sahils we are having, right?
Sir, Sahil K is here. G is also here, but he is not saying anything.
Okay, fine. So I hope all of you are understanding and you are paying attention. Please don't do
Yes,
anything
sir.
else. If you do anything else, then I'm going to ask questions to each one of you. You will not be able to answer. We're going to have the
Yes,
quiz
sir.
right now, right? So mass number is the number of protons plus number of neutrons. And if you want to find out the number of neutrons, send mass number in, take number of neutrons out, right? So mass number minus number of protons is the number of neutrons, right? That is the number of neutrons. And number of electrons uh, is equal to the number of protons is equal to atomic number. This I've told you because atom is electrically neutral. Okay, so ionization enthalpy, that also we have done. Then yeah, like there was ionization enthalpy, there is also electron gain enthalpy, like the amount of energy which was required to remove an electron. Similarly, there is energy released when an electron is accepted. So ionization enthalpy is when electron is lost, and electron gain enthalpy, as the name suggests,
When an
electron
electron
gain
is gained,
enthalpy. Yes, when the electron is gained. Can you see over here? Earlier that atom was having only one electron. Now it has accepted one more electron, right? And after accepting one more electron, it is now having two electrons. It's like the hydrogen atom. Hydrogen atom can
yes,
accept
sir.
one electron and it can become H minus like this. It can become H minus. Now the atom will gain a negative charge. It will become an anion. Like in the previous case, after losing an electron, it was becoming cation. Now it will become an anion over
Anion.
here. Okay, understanding this, right? So in carbon atom, if I ask you what is the number of protons, so you can see the number of protons are 6 because atomic number is 6 and atomic mass number is 12. So you can find out the number of neutrons also, right? This was the first example which I did it for you. right?
Yes, sir.
Yeah. Should I move ahead?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Now, come on, you have to answer. Huh? Come on. You have to find out the number of neutrons, protons, and electrons in this. Hurry up. Protons, neutrons, and electrons in this.
So the protons, neutrons, and electrons are 12.
Yeah. Is that right?
Yes, sir.
Others, I'm
Yes,
asking
sir.
them, is it right?
Everything is
Yes,
12.
sir.
Yes, it is 12. Next. Come on. Now, the number of protons, neutrons, electrons. Yes, is it difficult? So difficult.
No, sir.
Come on, answer then quick. Yes, Anushka is there with us. Anushka is there in the meeting. Anushka, are you there?
No, she's not there.
I think your exams are going on. Okay. Yes, can you answer this? Yeah, why are you taking so long? Come on, answer this.
Well,
See,
everything is 12. Protons,
every
neutrons, and electrons.
no, protons and neutrons are 12 like before. Protons and neutrons are 12 only. But electrons will be 10 because plus 2 meaning
Yes,
it has
sir.
lost 2
10.
electrons.
Oh, yes,
Plus
sir.
2 meaning it has lost 2 electrons. And as it is lost 2 electrons, now the number of electrons will be 10. Are you understanding this? Check.
Yes, sir.
Roman, are you understanding this? Roman, is Roman there in the meeting?
Yes, sir. He is there.
And Roman, why you are not responding? Roman, Roman number, hello, not responding.
Sir is saying
Okay,
that his mic is not working.
Acha, mic is not working. Okay. Come on, answer this. Number of protons, electrons, neutrons.
So electrons are 6 and neutrons and protons are 8.
Electrons are not 6. Atharva, check.
Sir, they are 10.
Electrons are 10. Here, see, Atharva, it has not lost 2 electrons, it has gained 2 electrons. So
Gain.
because minus meaning it has gained, plus meaning it has lost. It has lost. So it has not lost, it has gained 2 electrons. Minus 2. Right. So minus 2 is gaining of electrons. So 10 electrons are there, 8 protons and 8 neutrons will be there. Can you see this? Hello? Can you see this?
Yes, sir.
Yes, sir.
Yeah. चलो अभी ये बताओ carbon dioxide molecule. For the molecule, I've done this for you. See, you have to add for carbon. How many are there? Carbon, there is six electrons for carbon and 8 electrons for every oxygen. So 6 plus 8 plus 8 because 2 oxygens are there. So 6 plus 8 plus 8 is 6 plus 16 and that is 22. So 22 number of electrons, 22 number of protons and 22 number of neutrons will be there for carbon dioxide. Now earlier we are doing for only one atom. Now we are doing for the entire molecule. Are you comfortable with this? Now we are doing for the entire molecule.
Yes, sir.
Hello. One I have done, first molecule I've done for you. Next you will do on your own. Are you understanding? Hello,
Yes, sir.
Bela,
Yes, sir.
getting it, no?
Yes, I am getting.
Yes, come on, do it for sulfate. Now we have started with the radicals. You have to find out the number of protons, electrons, neutrons. And if you're having any problem, please tell me. Yes, why are you taking so long?
Sir, I sent my answer.
Yeah, don't send. Tell me your answer. Total number of protons, electrons, neutrons.
Sir, should I tell?
Yes.
Sir, I got protons and neutrons are 48 and electrons are 50.
Yeah. Have you got this answer, all of you all? Hello.
Yes, sir.
Have you got the answer? Children,
Yes,
are you able
sir.
to do this? For those who haven't got, pay attention over here. Sulfate -2. So what is the atomic number of sulfur? Sulfur is 16. Okay. Atomic number of sulfur is 16. Okay. S is equal to 16. Then atomic number of oxygen
8.
is 8. Okay. Or if I can write like this also. Sulfur is 16 is the atomic number, 32 is the atomic mass number. Oxygen 16 is the atomic mass number, 8 is the atomic number. So if I want to do the number of protons first, so protons are equal to the atomic number. So for sulfate, how I will do number of protons for sulfate? See like this. Sulfur is how much? 16 into 1. How many atoms are there? 1 atoms of sulfur are there. How many? What is the atomic number of oxygen? Atomic number of oxygen is
8
8. How
into
many
4.
oxygen atoms are there? 4. So how many number of protons will become 16 plus 8 fours are 32.
32. So the
16 plus 32 will become
protons and neutrons
48.
are 48.
So 48 protons will be there, and if you calculate neutrons in a similar way, that will also come as 48. But electrons, when you calculate, so it will be 16 into 1 plus 8
8
into
into
4.
4
But
minus.
it has gained 2 electrons. If you can
So
see
it will be minus in
minus 2
bracket
meaning it
minus 2
has, yes, plus
plus
gained 2 electrons. But in anyway, I'll just write +2 because it has gained 2 electrons. That's it. We are calculating the number
yes.
of electrons.
So sir,
So
it will
16
be
plus 32
50.
plus 2. So it will be 50 number of electrons. So 48 protons, 50 electrons, and 48 neutrons also. Are you understanding this? Yes,
Yes.
hello. Those who are not able to calculate, are you able to calculate right now? Those
Yes,
who are not
sir.
able to do it, are you able to do it right now? Yeah, is
Yes, sir.
everybody here?
Yes, sir.
Gayatri,
Yes, sir.
Sujal,
Yes, sir.
Yes, sir.
then Arya, are you able to solve? Arya Kazre, Arya, Aditi Ahir Rao,
Yes,
then
sir.
Trisha, Trisha, Janice.
Yes, sir.
Janice, are you able to do
Yes,
it?
sir.
Janice, I hope this is not going bounces to you. Nisi,
Yes, sir.
yeah, then Roman text if you're not able to unmute. How come you're not able to unmute, Roman? Then Sahil, both the Sahils.
Sir, only I
Sridhar,
am there. The other one is not there.
Sridhar,
Yes, sir.
Sukhada, Tanvi.
Yes, sir.
Yes, sir.
Come on, let's go back to the PPT and let us solve a few more questions. Now check this, what you have got. Sulfate, it is what I've explained. That is again shown over here. Okay, getting it?
Yes, sir.
Hello, Ayal.
Yes,
Is there
sir.
anybody who's not understanding? Is there anybody who's not understanding? If you feel if you feel shy to tell me over here in front of everybody, you can text me on WhatsApp if you're not understanding, if you're not getting any particular thing. Because if you fail to understand this, these are the basics, these are the fundamentals. If you fail to understand this, you fail to understand a lot which is going to come ahead in chemistry. Okay. Come on, do this. Those who will get this right, I'll give them an appreciation video with your personalized appreciation video with your name, and I'll post it on the group. Those who get this right. Personalized appreciation video for those who get this right.
So the protons and neutrons are 50. No, sir, the protons and neutrons are 47 and the electrons are 50.
Yes,
Yes,
sir.
sir.
I
I
also
got
got
it.
the
Yes,
same.
sir.
Yes, sir. I also got the same.
Yes, because there is an appreciation video declared for this, I'll not release the answer as of now. I want to hear all your answers first. Everybody, anybody else who wants to reveal their answer?
Sir, we got the same answer.
The same answer.
So same answer.
Anybody else who's got something different, or everybody
No,
has
sir.
got the same answer?
No, sir.
Yeah. So if everybody of you have got the same answer, all of you have gone wrong. You are like, huh? Why, sir? Why did we go wrong? Yes, I'll tell you how you went wrong. Okay, I'll tell you how you've gone wrong. You've gone wrong here in the number of neutrons. Okay, you've gone wrong here in the number of neutrons. So have a look over here. We were doing the phosphate molecule PO4 -3, phosphorus atomic number is 15,
15.
but atomic mass number is 31.
31.
Oxygen is having atomic number 8,
8.
but atomic mass
16.
number is 16. So if you do go by this, then the number of neutrons, so number of neutrons in phosphorus is 16. Okay, number of neutrons you have taken 15, but actually there are 16 neutrons. 16 plus oxygen is having 8 neutrons, 8 into 4. So the number of neutrons you have gone wrong. So I don't have to release any video because everybody has gone wrong. You will be getting 16 plus 8 fours are
32.
32.
48
So 16 plus 32 is
neutrons.
48 neutrons. You were telling me 47 neutrons. That's why you'll have gone wrong.
48
Number
neutrons.
of number of protons will be 47 definitely. 47 number of protons will be there, and number of electrons will be 47 plus 3. Because why 47 plus 3? Because 3 electrons
Because
it has
it has
gained. It is having a
gained.
charge of -3, and hence the number of electrons will be 50. Getting it?
Yes.
Hello, are you getting it? Yeah.
Yes,
So you
sir.
understood your mistake. You understood where you have gone wrong, right? Hello.
Yes, sir.
Yes.
Excuse me, sir.
So this is your
So can you tell me how did you
hello,
find the
Bolo.
number of neutrons?
Neutrons. See, number of neutrons. How did I find it that it was 16 in phosphorus? For phosphorus, atomic mass number is equal to protons plus neutrons. So atomic mass number is 31. Protons, we know that there are 15. So plus neutrons. So send 15 on the other side. 31 minus 15 equal to the number of neutrons. So 16 is the number of neutrons. That's how I found 16. 16 for phosphorus, 8 for oxygen, but there are 4 oxygen atoms. So 8 for the 32. So 16 plus 32 becomes 48 neutrons.
Yes, sir.
Got it?
Yes,
Yeah.
sir.
Understood how I calculated it?
Yes, sir.
Yeah. Yes. So this is what is about our protons, neutrons. Fine. So I hope you all have got enough practice, and then we'll stop over here because we've done. It's almost past 5, right? So 10 standard children must be waiting. So we'll continue with periodic table in our following class. Till then, good evening
Yes.
and thank you. And if you have any doubt, please post it on the group. Okay.
Good evening and thank you, sir.
Good evening and
Good
thank you, sir.
evening and thank you. Good evening and thank you all of you.